Hello, friends, and welcome back to For the Purpose Of, a podcast dedicated to the intentional integration of education technology. I'm your host, Ron Houtman, and today we have also Sarah Wood and Keith Tramper, both education technology consultants from Kent ISD. Today we wanted to dive into, at the very beginning, the essence of our podcast name, For the Purpose Of. In a rapidly evolving landscape of education technology, it's really easy to get caught up in the latest tools and apps. Every new piece of software promises us to revolutionize learning. Every gadget seems like it's a must-have for the classroom. But here at For the Purpose Of, we want to take a step back and ask a fundamental question. Why? Why are we integrating this new tool? What's the purpose behind adopting this app? These questions are crucial for EdTech integrators and coaches. It's not just about using technology, it's about using it with intention. Our goal is to ensure that every technological integration enhances learning, engages students, and aligns with educational objectives. We believe that understanding the why behind each tool and app leads to more effective and meaningful integration. It's not just about being tech savvy, it's about being purpose-driven. So as we explore various education technologies in our episodes, we always start with the purpose. We delve into how each tool, application, or initiative can enrich the learning experience, not just add to the digital noise. Remember that the best technological integration is not one that uses the most advanced tool, but the one that serves a clear educational purpose. So let's embark on a journey together, exploring the world of education technology, always guided by the question, for what purpose?
Awesome. Well, thank you for that great intro there, Ron. It's good to revisit the purpose behind what we're doing with this podcast and just remind our listeners of what we're here for. You did say Sarah would be here today. Unfortunately, she let us know this morning she is out sick. So it's just Ron and I today, and we're going to be talking a lot about computer science. As we record this, it's at the end of CS Ed Week, and teachers all around the world have been engaging in computer science, and we just kind of want to touch on that. Every year we kind of make a big deal of the computer science side of things. So we'll be getting into some big ideas around computer science and just some different ways that you can engage your students in computer science learning.
Yeah, it should not just be a month either. It should be the whole year.
Right.
But, I kind of like that it's in December because it does give, you think about it as a teacher, you can introduce a lot of this stuff to your kids. And then over Christmas break, when they're, at home saying, I'm bored, at least have some stuff they can do, right?
Yep. They can learn how to leverage those robotics and different things they're asking for Christmas, right?
Yep, totally.
All right, so let's start out with a question like we always do. And this week's question is, what is something outside of work that you've learned recently?
Well, I have to tell you, this week, I went to a cookie decorating class. So I know I learned about royal icing and how to make really good Christmas cookies. So there's a shop that's close to our house here in Grand Rapids. She's relatively new as a business owner, and one of the things that she decided to do to diversify her income stream was to actually teach classes on how to do cookie decorating.
Wow.
So I did cookie classes, and I learned how to do, the words are outline and flood, which if you look that up on the YouTube, you'll find all kinds of really cool ways to create really nice designs on cookies. So it was a great class, hour and a half of decorating cookies. Learned quite a few things I didn't know about, and I'm really going to up my game now with all my cookie presents that I bring to work, because if they stay home at my house, they're just going to get eaten, and that's not good for anybody.
Wow, that's awesome, Ron. That's a nice skill to have. And if it's anything like the TikTok videos, like, it's amazing when people can do that really well.
All right, Keith. So what did you learn lately then?
So for me, I went back to my early days of technology and decided I was going to build a new computer, something that my kids and I can use to play games or, design things. I like to Cricut and do some of that stuff too. So it was a fun learning process to go back and relearn like all the new things. I did it when I was younger, but haven't done it in quite a few years. So fun to see all the components and the different different ways they've changed over the years and how to put them all together and actually make it work. It's a really satisfying feeling to
So the
do that.
question is, did it boot the first time when you
No,
powered it on? No. Yeah.
no, I had the RAM in the wrong slots. That was
Oh,
a relatively easy fix. So
yeah. Good. I know that's the biggest fear always is the first boot. It's like, okay, does it turn on? And then shortly thereafter, does the magic smoke come out of the components? I've had that happen quite a few times. So
yeah,
yeah, I think, building your own computer, that's a huge skill. It's really scary for a lot of people, but to me, I think if you have anybody that can help you, or you've done it in the past, or just watch enough YouTube videos, I think just about anybody can build one. So it's a really cool thing to do. And
yeah,
the only problem is that when you build your own, you are the tech support for the box forever.
yeah,
Just like
for
if you
sure.
build a computer for somebody else, you are the tech support forever. It's kind of like the Thanksgiving problem. You go over and got to fix everybody's computer on Thanksgiving.
All right, so as we know, December is recognized as Computer Science Education Month. Today, we're going to explore the significance of computer science for students in kindergarten through 12th grade. We'll discuss why it's crucial for us as educators to integrate elements of computer science into our teaching methodologies and learning environments. This will help our students not only understand the fundamentals of computer science, but also apply them in various aspects of their learning journey.
So when we think about computer science itself, it's still kind of hard for a lot of people to get their heads wrapped around. Most folks think it's all about coding, and it's really not just about coding. There's a lot of other things that students should be doing, especially if we go back and look at the standards. So we think again of all the different kind of standards there are out in education. Computer science has their own as well. But some of the key pieces of this really fall into about 3 areas. And those 3 areas are coding and computational thinking, digital literacy, and safety. And the newest one is artificial intelligence and machine learning. So that's what you're going to see if you go to like Hour of Code. They've changed a ton of stuff to incorporate artificial intelligence, because I don't know if anybody even knows this. Mostly ChatGPT. This is like ChatGPT's first birthday. I mean, about a couple of weeks ago.
Yeah,
And we have come so far with this, of just the stuff that is coming out of it. This is going to be a huge deal from now until forever, or until Skynet takes over, or whatever the next thing is.
yeah.
So, Keith, when you think about computational thinking, what are you really thinking about when you talk to folks?
Yeah, so computational thinking to me is the foundational pieces of the educational skills students need to have in order to be successful in computer science. So if you look into it, there's 4 main ideas within computational thinking. The first is abstraction, which is being able to focus in on important information. And sometimes that helps you redefine a problem. So if you think about that, that's a skill we start in young kindergarten or young fives, right? Like all the way up through 12th grade, we're trying to help students learn strategies to focus in on the important information that they're looking at. The second one is debugging. That's finding and fixing errors, right? Like, yes, you do that in code, but you also do that in just about every other class too. So identifying patterns is the third one. It's the ability to look into things and identify patterns. We do that a lot in math. We do that in all kinds of literacies. So it's something that can happen as well. And the last one is decomposition. That's the idea of taking something and breaking it down into smaller pieces. Again, something that we do all the way down at early elementary and all the way up into secondary and beyond.
Yeah, you talked about abstraction there. I think that's the one that really throws a lot of our educators off, just because it's a really new term to them.
Yeah.
And it seems like I don't know what that means. So I always think about abstraction kind of in a couple different ways. So one is I always think about it like a simple map to find your way, instead of using every single detail about the streets that you're going to use. You're kind of looking at a big picture. Just like that map shows you kind of the important roads and places, but without all the tiny details. So in computer science, abstraction means focusing on big ideas and not every small detail. So it's like thinking, about maybe like the main steps to make a sandwich, like getting bread, adding fillings, putting it all together, without worrying about every little step, like opening the fridge, how to spread the peanut butter, the mayonnaise, or whatever. So it's really, solving problems, understanding things easier by taking that different view of things. But on the other hand, when you start talking about pattern recognition, then you're getting into real fine minutia and details. So it's kind of this big continuum of big picture problem solving, and you're kind of working your way down into this. Okay, now I need to solve individual details that are going to actually make up that whole picture. Kind of, I mean, you could almost think of it like a when you get a puzzle, like a 1,000-piece puzzle, right? Is if the puzzle came already put together for you, or you're looking at the front of the box, you can see what you want. If you scramble everything up and you say, okay, now I need to look for some patterns to be able to create this picture. Teaching our kids that, we always think about expert learning and what that might look like. To me, one of the real key portions that determines a person to be an expert or an expert learner is their ability for pattern recognition. And conversely, I would say too, especially with kids, maybe looking at the stuff that is not there, like what's missing. That's a key skill here too. And I think computer science really helps kids understand that whole entire continuum of learning. So when you think, Keith, about like the computing standards, what are some other things you're thinking about in that realm of, literacy and safety?
Well, yeah, it's funny you bring up the standards because I was just doing a workshop the other day with our MDE computer science consultant, and she was talking about the standards. And I don't know if you knew this, but they came out in 2019, shortly before the pandemic hit. And so, like, all the momentum around that just kind of stopped. So it's picking up momentum again. And what they're talking about, you mentioned AI and machine learning. They talk about how right now in the standards, yes, a lot of the things in the standards can apply to AI and machine learning, but they're going back and looking at revising those things as well so that it can include more of the artificial intelligence side of things. So in the next few years, I would assume we're going to see some more standards or adjusted standards to include some of that AI and machine learning side of things. And that's not necessarily done by MDE. That's done by the Computer Science Teachers Association. And they'll kind of give their recommendations down to the states, and the states will probably adopt that.
Yeah, it'll be interesting to see because I think, again, when I say we, you and I and all of our other front EdTech folks have been talking about digital literacy quite a bit for years and years. And it was mostly on the idea of just, being safe and not sharing your passwords and personal information with people. There's a whole new layer to this once you start throwing in maybe some of the new artificial intelligence stuff. So, literacy in the digital sense is kind of understanding how technology works, also about being safe, of course, being respectful to other people and responsible online. Probably a big one that's going to be coming up a lot, now and in the future is understanding and recognizing what fake news looks like. Because I've seen some pretty wild stuff lately about AI generated TikTok content. Like now you can just put a picture in it and you can give the AI your text and some voice sample, and this thing will build an avatar that's doing all kinds of stuff. And sometimes young minds do not understand yet what AI generated content looks like. I don't know if they have the ability sometimes to discern computer generated at that quality versus real life.
Mm-hmm.
And especially, with the ability for those algorithms to really push the engagement button for kids and especially the outrage button for lots of folks too. Because
Mm-hmm.
I think all social media platforms are completely driven on basically outrage and how much stickiness, they keep you coming back. And then sharing this stuff too is, kids really don't think a lot of times before they share something that is potentially untrue or just a flat out made up lie. So we really have to help them understand this, to navigate this digital world with some amount of knowledge and confidence going forward.
Yeah, I think you're speaking to the ability to have that critical thinking skill.
Yeah.
That's good enough to be able to recognize those things, but then also the ethical side of things as well, being able to recognize what to do with that information when it is made up or generated by AI, and how to present it.
Yeah. And, to the last thing, when we think about AI, the artificial intelligence, machine learning, Machine learning has been around for a while. Again, if we think about recommendation engines, all of us have gone to Amazon and we've seen hey, you might like this, even though I already bought that thing that you're telling me I should buy again. Or look, we're on a podcast app or listening to music recommendations, or watching Netflix, whether you might like this. Those machine learning pieces have been around for a while. The next layer, when you start laying artificial intelligence on it, it's really going to transform the way that we live and work. I think from those recommendation systems to things like the self-driving cars, which I'm still really terrified about, just because in Michigan we have snow, and I don't know how those things are going to drive on roads without discernible lines.
Theoretically better than a human.
You know what? I'm waiting. But when I see the things on video, like in San Francisco, when all the cars head and they all stop in front of each other and nobody can go anywhere, or the other one, I think I saw it was, I think it was San Francisco too, when they were getting mad about the cruise cars. All you have to do is put a traffic cone on its hood and it basically disables it. It thinks it's going to hit something. It's kind of like booping a dog's nose, like boop, up, put you in a zombie trance. But I think these concepts really, when we think about them all together, understanding how AI is going to really spark a lot of curiosity and creativity and open doors to kids coming up with some wildly innovative solutions to things. I think we're kind of at a new beginning here, propelling us to new abilities for knowledge use, gathering, and being creative. It's going to be pretty wild. I think for our teacher friends too, since you are our primary audience, thinking about how AI might be able to make your jobs way, way more easy. And that's getting a lot more stuff done that we would consider to be the things that aren't teaching, the administrative work. I think we're going to see some really big breakthroughs in that too, to help you be a lot more, I guess, I would say efficient really in your classroom, especially on the relationship and teaching learning side. Keith, what do you think of that?
Yeah, I think that's the promise of AI is being able to make us more efficient. That recommendation machine that you're talking about, being able to locate the kind of information we need quicker. There's so much promise in that as educators. But like we've been talking about, it's a balance between all of that, right? When it starts serving you things that are recommended for you, what are the things that it's leaving out? What's the information there? Because we already sort of live in echo chambers. We're kind of stuck in a space where we're only getting information that is reinforcing our own thoughts and our own ideas.
Mm-hmm. What happens when AI starts feeding AI, where all the content on the web, nothing's not generated by AI anymore?
Yeah.
What's that going to look like?
Yeah. And the scary part of that too is that AI is going to do that way more efficiently than humans will, right?
No, right.
So
I just think about political campaigns that are coming up in the next year or so, or 2 years, whatever. I think we're in perpetual election mode now, but the ability for politician-ish people or the consultants that work for politicians to create content so targeted to individuals based on all of the data that you may have given, your favorite platforms that you like to be on, like the Instagrams, the Snapchats, the Facebooks out there, to use the data your digital dossier that's on you to target you with individually created messaging. And again, back to the digital literacy stuff. There's a I would say a subset of adults out there that just don't have that amount of critical thinking to go beyond the thing that they saw on Facebook, which is sad. Just honestly, it's just kind of disappointing that we, the royal we in the United States and probably beyond, don't really teach this like as an ongoing thing. Once you're out of school, it's over with.
Yeah. Yep. There's one area of the standards called the impacts of computing, which was actually the focus of CS Ed Week this year. That focuses in on how technology impacts culture and social interaction, and then safety, law, and ethics. And what we're speaking to right now is really along the lines of culture and social interaction as we see it. I think you're speaking to confirmation bias, right? When we see information that we tend to agree with or reinforces our ideas, we tend to not use our critical thinking skills because it just reinforces what we know or think we know.
Yeah, to me, I think the whole idea of critical thinking amongst a large part of the population, to me, it's kind of depressing sometimes when I think about it. It's like, how can you not understand that all of these messaging places that you're getting, they're fine tuned for engagement and enragement, you know. But again, I know what we're living in. We're living in the attention span period for folks too, right? It's really hard when you've got so many of these messages coming at you, plus your regular life, and remembering to breathe from one moment to the next to really turn on your critical thinking head. So it takes a bit of skill and a lot of, I guess I would say, introspection and some amount of cognition to do that. And unfortunately, there's a lot of folks that, for whatever reasons, they're very much tuned into that. How can I be outraged today instead of how can I seek to understand? So big difference.
Yep. Well, on that note, why don't we switch gears into what educators can do to engage their students in some of these major issues and computer science learning altogether? So what are some of your thoughts on that?
So just again, thinking about Computer Science Month itself, I think there's probably 5 things I can think of in my mind about how we can better engage our kiddos, K-12 students and beyond. Maybe we should just call it PK to 20. Think about making computer science relevant. So we want to really show how computer science is kind of everywhere, from your smartphone to your favorite video games. I think the real world connections really spark some interest in this for students. Next part I think about is interactive learning. So platforms like Scratch and Code.org really offer some hands-on experiences where even really young kiddos can experience simple programs or games, making that learning most fun and practical. Even bringing in physical computing. So we have some things like, for even littles, like B-bots as an example. But I really like that many of the platforms have not just coding and looking at it on the screen, but actually like even a physical item that you can program, or a emulation of that physical item that you can watch and do things like Scratch, right?
Can I ask you, what are some of your favorites in terms of those robotics and integrated circuit kind of things?
Of course. So my favorite, I really like the microbits are a really good single board computer. We've got those, like the B-bots is another really good one. Dash and Dot, Spheros, again, physical objects that you can actually program and do things with, I think is really key because, I mean, just think about even from little kids to adults, Lego is cool, right?
Mm-hmm.
Building stuff is really cool. Having that ability to then combine the physical stuff with the digital stuff really makes that connection good for kids. I think the next piece of this, when I think about my list of 5 big things, would be collaborative projects. So how do we get our kids to work together? So whether it's coding, a class website, designing a small robot, working in teams, really just helping students learn from each other and see the collaborative nature of computer science. So that cooperative learning is a real big piece in here. I think 2, problem solving challenges. So competitions that are like inside of the hour of code are really great. Maybe a school-based hackathon can turn some abstract concepts into exciting, tangible goals. Maybe even things like Breakout EDU, which is a real neat thing too. A lot of problem solving in that. So thinking about how do we help our kids solve more real world problems. And I think finally is, bringing in folks from outside, guest speakers from maybe the tech industry. If you have folks that maybe parents that are coders, programmers, maybe are involved in even the ethics side of things, those experiences, when talked about to kids, can be really inspiring for students. So I'm thinking, the big thing we need to always do is just really ignite that curiosity and creativity in our students in this ever evolving field. And again, I think it's going to be pretty wild in the next years, just with the AI stuff coming out.
Yeah, I think everything you said in there is aiming at how you help students build a computer science identity, right? How they view themselves as computer scientists, because that's what's needed, right? And you see that in a lot of other subjects as well. There's a lot of talk about math identities, seeing yourself as a mathematician and seeing yourself as a scientist. The same thing applies to computer science. So all those pieces kind of lead to building that identity. I'm going to talk just about a couple other things. I earlier this week sent out a bulletin blog post on Computer Science Education Week, and I really love the impacts of computing standards. So I really focused in on some different activities you could do in the classroom that are cheap and easy to do, that really draw out that impacts of computing side of things. So the first one is focused on like technology as a social driver. And this comes from Diana Graeber. It's the idea that when technology gets introduced, a new game-changing technology like AI that we're experiencing right now, or like the bow and arrow when that came out, right? How did that bring communities together, and how did it push us apart? So just a thought activity with students, or something you could do collaboratively with different kinds of technologies that have been introduced throughout history, is just to take a deep look at when that technology was introduced. How did it bring us closer together? And in what ways did it push us apart? You can go check out that bulletin post. We'll make sure it's linked in the show notes there for more ideas and some links for resources for doing that. At an elementary level, we talked about computational thinking. Definitely go to CT for EDU. It's a great resource out of Michigan State that focuses in on computational thinking and really explains those 4 areas a little bit better than I did. So sometimes, most of the time, teachers are already using CT. It's just a matter of shifting the language you use. You heard us say things like abstraction and decomposition, big words for young kids. But when you can tie those practices that you're already doing in class into something that means something in computer science, that goes even further. And the last thing is Hour of Code. It's a really cool thing that happens every year all around the world. Even if you missed it this week, by the time you're hearing this, it'll probably be the week after CS Ed Week, but definitely go check out the Hour of Code. Even if you know nothing about computer science, it's a really great place to start and give your kids a chance to get hands-on interactive learning with some coding.
Yeah, and it never shuts down.
No.
It's around year round, which is always great.
Yep.
All right. So when we think about, this last part where we just think about engagement with our students, there's quite a few things that we can do. I think as teachers, it's always the difficult part of, where do I insert these things into my particular class? And also as a teacher, where do I myself find these things to be able to maybe do my own small amounts of professional development, professional learning here and there. So we have some really good resources that I think you would really like to know about. We're going to put them in the show notes. But Keith, why don't we talk about just a few that we know about that are kind of at the forefront here?
Yeah, so we have a lot of things that are going on. Sarah right now is running the EdTech Cheer, which is all focused on artificial intelligence. So far, I forget how many days in we are at this point, but there's been lots of great information that's helping build a foundation for many teachers. There's well over 100 teachers involved in it, sharing their different ideas. It's a really cool thing. And the best part about it is, while sketches end at the end of the course after 12 days, you can still go back and access all the materials for as long as you want. So we'll make sure that's linked in the show notes so you can go check that out. Also, we do have a couple of grant things that are coming down from the state level. We have 99B and IET grants. Both of those are focused on computer science. They are mostly done from the district level. So your district can apply to get funding to provide professional development for your teachers around computer science. And as part of both of those grants, one of the things you need to do is script workshops. That is a way for districts to align their K-12 computer science initiatives, develop a CS vision and some goals to reaching that. So I'm one of the trainers in the state. There's 4 of us, and we've done a number of different workshops around script training, and every time it's just a really great experience getting a bunch of district voices around the table to improve computer science outcomes for students.
My favorite of the year is always EdTech Cheer from Sarah Wood. So a lot of really good activities. It's kind of like the EdTech Advent calendar. The only thing I wish it came with would probably be like a different block of cheese every time you did an activity. Or some other sort of Advent calendar I've seen at the Aldi, like the one with adult beverages, which I have never bought one, but it always looks interesting to me. I don't know. Thanks again for all those really great resources, Keith, and we'll look forward to having Sarah back on our next episode when she's feeling a little bit above the weather. It's that time of year. Makes lots of people indoors and just happens. So thank you all for joining us on this episode of For the Purpose Of. We really appreciate you tuning in. If you like this podcast, we'd love it if you'd share with a friend on your favorite podcast app. Make sure to give us a star rating. Those are really helpful too, and making sure that other people are able to find our podcast.
Yeah, so we would love to hear something that you learned recently. Definitely come share that with us and share your ideas about computer science and how you're incorporating that into your teaching. You can do that by going to bit.ly/IamEdTech. We always welcome your feedback there as well. And you can always reach us at edtech@kentisd.org. We'll catch you next time on For the Purpose Of.
This podcast is a service of Ken ISD, produced by Ron Houtman, Sarah Wood, and Keith Tramper, and edited by Keith Tramper. Our theme music is Neon Nights by Scott Holmes Music, and our ad music is Vienna Beat by Blue Dot Sessions.